Johan is going to share with us about they've been doing amazing things and he's developed SeeBlocks. So if Johan, if you want to go straight into it, please.
Okay. Hello everyone, I'm Johan Kok. Let me just switch on my screen sharing here. The solution that we offer is called SeeBlocks. It is to make it easy and possible for teachers and schools to offer the technical subjects like electronics technology, for example. Just a little bit about myself. I'm an electronic engineer. I've been in the industry for the past 20 years or so, and I have a passion for technical education because I can see the need and I can see that it will create a better future for many children if we can push them in that direction or guide them in that direction. From that came the idea for the SeeBlocks. In total, we've won 4 awards and recognitions, both locally and internationally. So a quick word about the problem that we're addressing in South Africa. As you can see in that image, 7 of the top 10 in-demand jobs in South Africa is in the technical and engineering space. That's a huge shortcoming. And the data from universities across South Africa shows that only 14% of engineering enrollment ever get their qualification, with an 86% dropout rate. And at the moment, there is 40,000 unfilled technical and artisan jobs in the country that cannot fill those jobs because there is just not people qualified to do it. And so that places huge responsibility on schools and teachers and the whole education system in South Africa. And the biggest reason, so as you can see, less than 4% of high schools actually teach engineering and technical subjects. And the 2 biggest reasons given is shortage of technical teachers and a lack of funds. So that brings me to our solution. The SeeBlock solution combines interactive online content that is in line with the CAPS curriculum, together with practical experiments, because that's required for the technical subjects, and progress monitoring. So the best way to explain what our solution looks like will be to give you a demo and or demos. So the first of all is I'll switch to just show you what our content looks like online. If I go to home, sorry, courses. So here's a list of the courses we currently have. So I'm going to go into this one. EE Fundamentals. It starts off with explaining the basics of electricity. As you can see in these titles, lots of videos, interactive or videos to explain concepts, and then quizzes to test the person's knowledge after that, and also experiments. So I'll explain the experiments a little bit more later, but just to show you what the experiment looks like from a content point of view is you get a circuit to build like this with some explainer text, and you're asked to do measurements. So in this case, we ask him to measure the current at that point. And then they have to do those measurements and type in the value here, and that's how we see if the student actually built the circuit and if the circuit is working. So we've got lots of videos. Videos are very powerful
to do with voltage.
Explain the abstract.
Well,
Yes, sorry. Videos are very powerful to explain the abstract concepts in electricity. So you can go ahead and play.
To do with voltage. Well, the water molecules in tank 1 has a higher potential to do work than those in tank 2, even when there is no water flowing between the tanks and thus no work being performed. It is this potential difference that can be utilized to do some work. So let's open that valve. Immediately you can see the water molecules start flowing down between the tanks and in the process turning the water wheel. By allowing this flow of water, one is actually reducing the potential difference between the tanks by converting the potential difference in energy into real work being done by turning the wheel. If you have a battery specified at 1.5 volts, it means that there is a potential of 1.5 volts between the positive and negative terminals of the battery. If you connect the battery to a circuit that allows for the flow of electrons from the negative to the positive terminal,
thanks. And the next video will show how you actually build these circuits. So just to give you a short, usually schools that do offer engineering and technical subjects like electronic technology, there is a lab component or a practical component in that's mandatory by the curriculum. So we solve that unique solution that enables you to build circuits as easy as you can build puzzles, and you don't need a practical lab for it. You can sit on a normal school desk with a multimeter and build these circuits and basically do the practical component of the subject. Okay, you can go ahead with the...
I'm going to start with building my very first simple circuit. So over here we've got the positive terminal of the battery, and then I go through I connect the LED light emitting diode LED to that, and then current limiting resistor, always very important, and then the negative terminal of the battery. Now as soon as I connect this, the light should come on, but it doesn't. That's because the LED is the wrong way around. So if I turn it the other way around, we've got a working circuit.
Okay, you might have a lot of questions about the technicality of that. You know, what is that thing? How does it work, etc. When my presentation is done, you can ask questions about it. It works with magnets, in short, and you can also visit our website for that. So then the last part is the progress reporting, which is important if you have kids working on their own time. You want to look at that. So I'll just show you a quick demo of what's available there, 1 or 2 reports. So the grader report is one of them. Here I selected a specific group. In this case, it's students at TUT. And there you can see all the activities in this specific course and what each one of them got with that activity. To those teachers out there that's familiar with Moodle, you'll see this is based on a Moodle backend. And another report here is, again, I'll pick myself this time. And so this gives you a list of the different courses and which ones have been completed by a student, and yes, how much what's the marks they got on that. And then just the last report, the user report. So I can pick a student from here, and then I can see for a specific course each activity, what the weight is of that activity, the grade that the user got, feedback if any, and so on. So yes, that is our solution in a nutshell. Benjamin Franklin said, "Tell me and I forget, show me and I may remember, involve me and I learn." And that is our philosophy, especially with technical subjects, is to involve the person in the learning process in terms of practical experiments. Thank you. And that's our website for those who are interested. Thank you very much. Any questions? What kind of magnets do you use? Neodymium magnets. The magnets makes the experience of building circuits so much easier and simpler. You just click the little blocks on, they stick to the magnets.
Yeah. Johan, have you got a kit nearby to show people what it looks like?
Yes, yes. Okay, so here's kit 1. So there's several kits. This is the first of them. And I'm going to tilt this slightly. So if I open it, in there you'll see this is my own kit. So I built a circuit as part of some experiment. And there's the battery connector. Yeah, so let me just take this base out and show them. So here I've got the base. And it's as simple as, so there's currently a circuit of a current source going through 2 LEDs. And if I want to replace that component with a different one, I just take it off. And I take a different component and click it on there. And that's it. So it's as simple as building Lego blocks, but you building working electronic circuits. To those who's interested in how does this work, on the top you've got the symbol for the specific component, and on the bottom you've got the actual component soldered on. So that's how it works. If you go to our website, there's a lot more information there explaining it.
Do you think SPACE children, so grade 7 to 9, who are doing the introduction, would benefit from the kit?
Sorry, Karen, your voice broke away there. Just ask again.
Your grade 7 to 9s, would they benefit from it from a technology point of view?
Yes, they will, because electricity is part of those grades. Even though it's so the first part, this EE fundamentals course that I just demoed to you guys, that is very applicable to grade 9 and grade 8, even grade 7. Yes. And I can, speaking of grades, I can say, although our content is based on the CAPS guidelines for electronic technology, we go from the assumption that you don't know anything about electricity and electronics. And we explain a little bit of atom theory first and take it from there. And we've just recently had a mother who did this with her 11-year-old boy. And he passed it. He flew right through EE fundamentals, and she went on and she bought extra courses. So I was surprised that a boy at his age can do it and understand it. And I think it comes down to the thing: if you explain something simple enough, younger people can understand it and learn to love it.
Yes, I do agree with you. And there's such a gap in the knowledge that I think your product has lots of value, lots of people, in terms of making electronics and the understanding of all the different theorems and theories really simple and easy. So I hope the people today see the value in this amazing product that you've developed.
Thank you.
No, thanks for sharing. To remind everybody, there is the website of the slide deck where you can find all of Johan's details as well, and you can contact them for more information to get these kits and the programs into your schools. So again, it's a physical building, but it's all you test it all digitally. So a really nice combination between the two. So thanks, Johan. Thanks so much for sharing.
Thank you, Karen. I saw one comment there passing by that says, I wish I had this when I was in school. Now, if I had to count all the people that said that to me, you know, during all my interactions with people, it was actually amazing that so many people said this. And the way practical electronics is presented today is still the same as it was done 50 years ago. So we've changed that, and that's the best feedback I can get. You know, it's from a child that's 11 years old that understands stuff that only a grade 10 was supposed to understand. Thank you very much for the opportunity.
Oh, no, thanks for sharing.